problem 40 of Neetcode 150, copy linked list with random pointer. Okay, so let's read the problem. You are given a head of a linked list of length n. Unlike a singly linked list, each node contains an additional pointer, and it is called a random, which may point to any node in the list or null. We have to create a deep copy of the list, and the deep copy should have all the nodes, and all the nodes should have a value, should have an x, a random, and we have to return the head of the copied linked list. Okay, so it might seem a little bit daunting when we look at this. So many arrows pointing in all the directions, but let's just go ahead and try to make this problem a little bit easier to conceptualize. So let's say that we have a linked list that has a 1 link or pointing to the 2, and the 2 itself is pointing to the 3, and 3 is pointing to the 4, and the 4, let's say it's the last value of the linked list, so it is pointing to none. All right. So what they're basically telling us is that each node will be pointing to the value to the right, but it also has what we call a random pointer. So the 1 might be pointing to the 4, for example. The 3 might be pointing to the 2. The 2 itself might be pointing to the none. And the 4 might just not be pointing anywhere. Okay? So to create a deep copy, we are going to have to create a hash map where the keys will be basically the node's value. Okay? And the value will basically contain the node's value, the next pointer, and the random pointer. But a hedge case here is, let's say we start our hash map and we add the 1. And we said the 1 points to the 2, okay, but the 2 does not exist. So what do we say to our hash map? We're pointing to a node that does not exist. And our random is also pointing to a node that is not in the hash map. Okay, so we are going to have to take that into account and say that if we don't have a value of the node that we are pointing, we are just going to create a holder for the moment. And also, what if we are pointing to none? Okay, so what if my random points to none? Well, this is something that we actually want to take care of, because if our next or random points to none, we might gonna get an error which will break the entire deep copy or the hash map. All right, so let's go ahead and try to code the hash map. So first of all, let me use a default dict, and I will create my hash map. So let's call it the deep copy, and this will be equals to the default dict, which is inside the collections. So all right, and now this is where we want to make sure that if our next or random is pointing to a key that does not exist, well, we are gonna have to automatically create a new node object for that missing key in the hash map, and we are gonna do so by using a lambda. So we are gonna write lambda lambda, and this way we can actually set the default value to a node, which is gonna be just a placeholder. It's only gonna have a 0, okay? Because we know that in our actual node object, which represents the value of each keys, inside this node, we want to have a value, we want to have a next, and we want to have a random pointer. But if it does not exist, we are just gonna set it to 0. Okay, so good. This is done. Um, and we also have to make sure that we take into account the hedge case where the random or the last key is pointing to none. So let me just create a deep copy um, with the key none, and it's going to be equal to none. Okay, otherwise we are going to have an error if one of our pointer is pointing towards none. So we have to set that. Great. So after this, well, we will go through every single node in our head, and we are going to create the key, which is going to be equal to the value. And also inside our hash map, for each keys, our values will basically be composed of val, next, and random. And this is going to be our node object, okay? So let me basically had a variable that will be equal to head, so we can go through the node without losing track of our starting value, which is the head. So we can call this the runner, because it's gonna run through every single node, and this is gonna be equal to the head. And while basically the runner is not equal to none, right? What we are gonna be willing to do is in deep copy at the runner, so it's gonna be equal to a value. And now we might gonna use a syntax that might be unfamiliar. So we are actually gonna use a dot val here, because our value is actually a node object, so we can access specifically val or next or random within this this value. So let me just copy this and create the other components of the value. So we are gonna have inside our value object, we're gonna have a val, we're gonna have a next, and we are gonna have a random. Okay, so this is what we want to actually hold for every single keys, and this way we are gonna create a deep copy of the current linked list. So what do we want the val to be equal to? Well, basically it's gonna be the value, right? The next is gonna be equal to basically the next itself. And remember, the next is not going to be in the hash map. So this is why we have to create, well, this is why we use a lambda nub 0. We're going to create the key of the next and a placeholder for the node object until we actually get to that node that we're pointing at. And the random is basically dot random. These are the values we can access from the linked list. Okay, and after this, we want to make sure that our runner is going to the next node. So boom. Now basically they are asking us to return the head of the copied linked list. So how do we do that? Well, we are basically going to return the copy of the original head, and we are going to do so by saying return the copy at the key head. So, and I was also about to forget an important point here. I said basically in the node object of the current value of the runner key, I set the next basically to a value, right? So runner that next and runner that random. But actually, this is not the correct way to proceed. It is great to do this with the value because we are returning an integer, but current.next and current.random actually refers to the entire node object of that other node that is attached to. So we are actually going to have to return the entire value of the the hash map at where the key is equal to that next value, right? So same process here, right? So it's going to be runner dot random. Okay, so this is quite important to add. And now we can submit the problem, and boom, it works. All right, so I hope you learned from this video, and I really hope to see you in the next one. Bye bye.